Okay, lastly, we are going to discuss more in the termination of trends and the behavior of which how a thread ends or terminates whenever a process is finished. Okay? So, in programming with threads, there's actually what we call termination of threads. A thread automatically ends when the code block finishes executing. When there are two or more threads running, terminating a certain thread is important because again, in order for a process to be efficient, it needs to process or to end the current program or the current processes faster. So if there are multiple threads with the same processes running and a certain thread finishes ahead of other threads, the process should communicate to other threads to stop the operation and reduce the processing expense. And it's really important that multiple threads communicate from one another in order for it to be efficient and reduce the processing expense. Okay, and just to give you an example of this one, this is a sample program which implements the termination of threads. We have here the myRunnable class, which extends to a thread. Okay, so this is the void run. So what happened here is uh, we are printing numbers 1, 2, and 3, and there is a thread sleep here. So it's actually a 1 millisecond sleep or 1 millisecond delay. So whenever the program exits before the 1 second delay, it will only output 1, 3, and 4. Okay, so let me just show to you here the implementation, which you can see here that whenever we are executing this is actually in millisecond. So knowing that delay is 1 second, it will not even finish the processing, but it would stop and halt the thread in 1 second. However, we're going to run this in milliseconds. So what we have here is we are going to start the thread in T1, and in T2, in T1 again, we are going to interrupt, which are going to end the process even during the sleep time of the program. So we're expecting that whenever we are halting this one immediately, it would automatically go into the catch or exception because the thread finishes even it's not yet done processing everything. So the output of this one would be 1, 3, and 4. And the total time is 0 seconds. So whenever we didn't actually run this one, this program will output 1, 2, and 4. Okay? So in terms of synchronization of object access, we all know that whenever we are having a software or database itself, we are accessing the same data within. But it's a different case to case basis. Whenever there's a software like bank, you are not able to access the same account from different users or different application. For example, land bank, you will not be able to access your account if it's online on your phone and if it's online on your PC, which for the sake that it's really important for even the bank softwares to have limited access in order for it to increase in security, at the same time the behavior of the software itself. So there's actually what we call race condition. A race condition occurs when two threads access a shared variable at the same time. So this usually happens when there are the same database with different threads accessing it at the same time. So what's happening here is the first thread reads the variable and the second thread reads the same value from the variable. And what happened here is whenever the threads access the same resources, there's actually what we call race condition, which is an error of the hardware of a computer. So sometimes it becomes laggy, or sometimes it halts, or even it does processes that's not common or unnecessary for a user. So what happened here is the first value that has been preserved is the value that's going to be used or preserved in the accessing of that variable. So it's actually something that even for us users or even developers should consider, because most of the time race condition happens in softwares that is being used by certain companies. Okay? And again, race condition occurs when two threads access a shared variable at the same time. Okay, to solve problems such as race condition in a program, the lock object is used to control the threads when we want to manipulate a shared resource. And this type of solution to avoid race condition is somewhat like this. Like whenever there is a thread running, you are locking that thread or even the resources that it is accessing. So what happened there is whenever it's in the lock, or it uses the lock object, you will not be able to access the resources and you will not be able to access the thread while it is running. So it's a good thing to add this in your software, because for security purposes, that whenever you are accessing a resources, it also disallow external accesses from different users within the same database. Actually, Java library has this. So it defines a lock interface in several classes, and reentrant lock class is the most commonly used class. Okay, so to give you an example of this one, it's just here in the lock balance change lock. So this is the data type lock, and this is the object of the data type, which is the balance change lock. Okay, so you just need to declare this or instantiate it in the class. And after this will just be able to use this one. So balance change lock to lock. And then whenever you're finished already processing, you use the term unlock. Okay? So however, this sequence has a potential flaw. If the code between the calls to lock and unlock throws an exception, the call to unlock never happens. And for example, you've used the lock or unlock object, but however, there is an error within the code. Meaning, whenever there's an error, our code eventually halts, which is we are trying to avoid, because especially in banks, we can have an error in our software because it may cause something that's not good. At the same time, it would eventually affect the company or the client. So that's why we throw an exception, that we are expecting that whenever there are errors, we are also be able to catch the error. Okay, so what we happen here is we actually add this block of code, again the try catch block, but this time we are going to use try finally. So unlike the try catch block, whenever there is error, it will automatically falls in catch, but in finally, whether there is an error or not, our program will still be unlocked. So it's something that we need to consider, because data is somewhat important even for everyone. Just to give you a picture of a lock, just like what you can see here, it's actually a telephone booth. So whenever there's a telephone booth, like the old telephone booth, whenever there is someone using the telephone, others would wait outside. Or they will not be able to enter the telephone booth until the certain person finishes calling. It same goes with visualizing locks. A telephone booth can only accommodate one person, and just like multiple threads, that before a thread runs in the same resources, it must first wait for the certain process to end. So that's how important visualizing locks are. Giving priority and at the same time understanding the behavior in order for us to increase the security of the software that we are running. Okay? And just to give you here an example of how bank account thread runner happens, or how withdrawals, how deposit happen within a bank software. Okay, so now what we have here right now is actually a sample code which mimics the bank behavior. First is we have a thread for withdrawal of an amount, which has a parameter of an account, the bank account of that person, the amount that it's going to be withdrawn, and the count or the times where the user would withdraw. Okay, so we have here a current loop, which basically repeats the process of withdrawal dependent on how much you want to withdraw, which you can see it here. And there's actually a delay. Okay, so next one is we have a deposit runnable. So the same as with unlike withdrawal, what happened here in deposit is you add money to the bank account. Okay, so the next one we have here is this is the code that you can try. Okay, the next one here is the bank account. So the bank account is a class that holds more of the different locks that we're going to process in. So first is we have the data type, or we have the class name, bank account. So what we have here is a default data type whenever this is called. So this is actually an inheritance, or we calling the balance change lock. And after which is after implementing this one to deposit an amount, there's actually a balance change lock here, meaning you will not be able to access the program while it's in process. So we have it here. So what happened here is when depositing, it shows the amount. Whenever there is being withdrawn, new balance here is being outputted. Okay, so this is for the deposit, and this is for the withdraw module. So we are also calling here the withdrawn class that we have used earlier, or we have seen earlier. So this is it. Okay, so it same goes with get balance, that you are returning the current balance of the user. Okay, just to mimic this behavior, let's just show this main file. So number of repetition, we are going to withdraw, and we are also going to deposit, and show the behavior that, knowing that this is a multi-processing behavior, you should see that both processes should output the same time. But we're going to show how the bank works, or how lock works. Okay, so this is the code. So let me just run this one. Okay, so what you can see here, oops, sorry, this is not what I'm trying to run. Let's run this file. Okay, so it finishes in 1 second. So what we see here, let me just scroll this up. Okay, so what we have here right now is first is depositing a new account. So after depositing a new account, the user will be able to withdraw 100, because there is a 100 in the account. So you can see here that there's a new balance at 0. And again, depositing amount, and there's a new balance here, 100, which we can see here that basically that there is the withdrawal method waits. Here is the withdrawal, this is the deposit, which before we all know that whenever there are multiprocessing, both of these functions run at the same time. But this time, before the user is able to deposit, to withdraw, it first waits for the user to finish depositing. And that's a feature of luck, that this thread will not be able to run until this processes finishes. So it's really important for bank data or bank system that runs these processes, and this is the one that mimics that behavior. So you can also try this one, and you can also mimic the synchronization of the module, or synchronization of the threads in this module. And that's it, and see you again in our next video.